Hello everyone, welcome back. I have posted the two other videos which you're going to watch concerning the loops. So in them I have introduced the two other types of loops, which are the for loop and the do while loop. And there are a lot of examples in these lectures. Please, I noticed that many students are not following up with the lectures that I'm uploading. Okay, so please follow up with them, all right? And you have to use them in order to be able to solve the lab problems. What I'm gonna do now, based on some of you guys who asked for more examples, I'm going to give you some more examples. But before that, I'm going to review a little bit the for, the while, and the do while. So in the for loop, you have three parts between brackets. Okay, these parts are the initialization, the condition, and the incrementation. What we did, as I mentioned in the lectures, is that we put all those parts, instead of being distributed like they were in the while loop, we put them all in one line, separated by semicolons. As you can see, it's so important to remember that they're separated by semicolons. After this line comes the body. If somebody who doesn't know programming reads this, he will not understand how the for loops works. Why? Because it actually starts with the initialization. So this flow chart is showing me how it works. So this starts with the initialization, so which is the first part. Second, it will check if the condition is true. And as I said, as I always say, it's like a yes or no question. So if it was true, you do what you do after the condition is that you go to the body. Although if somebody reads it, he will think that he will do the incrementation. No, the incrementation is done after the body. So initialization, condition. If the condition is true, we do the body of the for loop. If it's more than one line, we will have braces. We will have the block enclosed between curly braces. So that's the body of the for loop. After the body, we'll do the incrementation phase. After the incrementation phase, we have to check if the condition is still true. And we said we will repeat as long as the condition is true. The only way in here so far to break from the for loop is for the condition to become false. So when the condition becomes false, what we do is that we continue with whatever statements there are after the for loop. So whatever statements you have after the body are going to be executed when the condition becomes false. This is just a revision. And in here there's a revision. I put you a revision on the while and the do while loops. So in the while loop, you simply have a condition and the body. After the body, if the condition was true, we execute the body. After the body, we check the condition again. Okay? And as I said before, in the body, there should be some statement that's supposed at a certain point to make the condition false, or else the while loop will be an infinite loop. So you only, in while loop, you only execute the body of the while loop if the condition is true. In the do while loop, you're telling the compiler, so the do while loop, the message that you're telling the compiler is to execute the body regardless whether the condition is true or false. So execute the body at least once regardless of the condition, whether it's true or false. So the body will be executed the first time, then I will check the condition. If the condition is true, then execute it again. If the condition was false, you exit and you continue with whatever statements you have after the do-while structure. So the message here for the compiler is that the body is executed at least once. And the other thing, even if the condition was false, it's going to be executed at least once. And how it looked like is that the condition and the while are put after the body. So it's like the opposite. It's put in a different order. Very simple. Don't worry about it. Not too hard. Okay, here I have set to you some examples which I want to take from here and go run them in the GDP compiler for simplicity. And I've noticed that many of you actually submitted your homework using the compiler by sending me the link, and that was actually good. Okay, so what do we have here? Let's check what we have here. We have a variable x. So the loop continues, goes while x is less than 10. So as long as x is less than 10, we're going to loop, okay? And x increases by 1 on every loop, okay? So this is the for loop, x equals 0, x less than 10, x plus plus, and what am I doing in the for loop body? I am actually printing x, okay? I'm printing x. So the body of the for loop is just a printf of x. We're printing x if we run it. Okay, so these are the different values of x. Started with 0 as expected because we started it with 0. Continued 1, 2, 3, 4 until we got to 9 or until we got to 10. So the last value of x was 9 because I said the condition here x is strictly less than 10 and not less than or equal 10. So when x becomes 10, it will go to the condition and it will break. Okay, it will exit the loop. All right, gotchar here, we use it to hold the screen in your Visual Studio compiler. Let's get back to our word loop, our word file. Okay, so let's now try this one here. So this is the same. So what am I doing here is that I'm doing the same loop using the while and using the for. So the same loop now, but using the while, okay? All right, so in here we're using, instead of having a for loop, we actually had a while loop, and we did the initialization phase first. The condition is in the while, between the while brackets, and the incrementation is inside the body of the while loop. So if we run this, it's the same as the other one. It should give me the same output, as you can see, from 0 to 9. What happens if I removed x plus plus? Okay, stop. All right, let's stop it. If we removed x plus plus, so it's doing that because we have getchar. Okay, so if we remove x plus plus and now run again, what will happen? It's supposed to give me an infinite loop. So it's an infinite loop. You can't find an end to it, and it's always it's always printing out 0 because we didn't increment x. Right, so x will always be 0, so it's a mistake. You have to always make sure that you change the condition. We're stopping compiling here. You have to change the condition. You have to do something that would make the condition false. So that was, I'm going to post this file too so that you can see, you can have the code, okay? This is a do while loop. Let's look at that too. So that's the same thing, the same, yeah, but in this case, okay, what do we have in this do while loop? Let's look at it again. So I have x equals 0. This is the body of the do while loop. And the condition is while x is not equal to 0. Is the condition true? For those who said false, that's true. The condition is not true. The condition is false because x is not equal to 0. But even though the condition is false, yeah, the body was executed. So let's run and see that it's going to execute the body even if the condition was false because it executes, then it checks. But what you noticed is that it didn't continue checking. So let's alter it to have, let's say, x plus plus, and here let's say x less than 10. Then it should look like what we had before, and instead of a hello world, let's say you want to do to write down x, so you put a comma here. Okay, let's run that now. So it's the same one as before. Did the same thing? Did it do the same thing as the while loop that we did before? Yes, it did, from 0 to 9. So I could ask you this question in an exam. Would this do while and the while I showed you a minute ago, will they give me the same output? The answer is yes. So what's the advantage of the do while loop? The do while loop didn't have an advantage here, but it had an advantage when it executed the body even if the condition was false. Let's look at this, another example. Please, you can always pause at a certain point, do it on your computer, and then continue the video. That's also, you can do that too. Okay. Let's look at this code here. Let's do this code. All right, so let's look here. All right, so I have number. You have two variables, number and sum. Okay, they're both doubles, and when we say double, if you still remember from our notes, double means double float. Okay, and when you want to refer to a double float, you can put in the scanf LF. Okay, or you can put F. They will both work. All right, so the body of the loop is executed at least once. You have here a for loop, a while loop, a do while loop. Excuse me, so it's a do while loop, yeah? So this is a kind of loop that is not counter controlled. So as I have identified in the previous lectures that you see on the channel, is that the loop doesn't have to always be counter controlled. We can have loops that are controlled. We call them sentinel controlled loop, in that they are controlled by the input from the user. So when the user inputs a certain value, the loop will stop. So what are we doing here? To do that, it's a good idea to use the do while loop. So what do we have in this do while loop? In that, I'm asking the user to enter a number. Okay, definitely it's a double. Okay, we input it in number. I'm going to add this number to sum. You see, always, as I told you, always if you have a cumulative sum, you always start with it, we start with it as 0, okay, so that we can add up values to it. If it was a cumulative product, we start with 1, exactly. Okay, so enter a number, we input the number, we added it, plus equal means add it to sum, which means, let me put it here for those who forgot it, which means that sum is equal to sum plus number, right? Okay, and I have put it in a comment because we don't want to do it twice, right? Okay, so that's what we're doing here. We're adding number to adding up sum. When are we going to stop? When the user input what? 0. So I can put here enter a number or 0 to exit, right? Okay, so if you want to exit, enter what? Enter 0. So enter a number or 0 to exit. So we have all the sum here. When the user inputs 0, the loop, we will break the loop. Okay, and this is an example of a do while loop. Don't forget the semicolon, which doesn't appear in a while loop. It appears in a do while loop, this semicolon, if you have noticed. So here I can print out the sum. Some of you were asking of a more sophisticated example with average, let's say. So I would write double, let's say average, or without double average. We can do that too. So yes, so average is equal to sum divided by we didn't count the number. We can here also count number if you want to get the average, you want to know how many numbers were there. I don't know how many numbers were there, so I would put here integer count equals 0, or in that case it started with 1. Okay, so let's start with 0, and we're going to put here count plus plus. Okay, in this way it will count for me, and in here we divide by count. So count is an integer and sum is a float or a double, so the answer is going to definitely be a double because one of these two operands is a double. And finally we're going to write a printf to print the average. So the average is %lf if you wish, comma, and average. Okay, and let's have a \n just for neatness, and when we go to the end we always remember our semicolon. Let's run this program and we give it, say, 10. Lost connection. Let me try again. Okay, so 10, let's say 20, 30, 0. We will note that the average is 15, so he considered 1, 2, 3, 4. He took them as 4 numbers because it dealt with 0 as if it was a number. Again, this backslash was by mistake. It doesn't affect your run. So what I'm trying to say is that it divided 60 by 4 because 60 divided by 4 is 15. So it considered the 0 to be a number as if I'm getting the average of the grades. It considered them to be 4 grades, although they are 3, and 0 is just used to control my loop. So to solve this is very easy. What you do here is you do count minus minus so that the one that was added for the 0 is removed now. So sum would be back to 3. Okay? Count is going to be back to 3. So let's run it now. Again, 10, 20, 30, and 0. And now the average is correct because 60 is divided by 3. So what we did is that we did count minus minus so that it doesn't consider the 0 to be a grade or a number. Okay. There's a note here that I wanted to show you also, is that I is when it's defined inside the for loop, okay, it can only be seen inside the for loop. When you exit the while loop, it will not be there anymore. So to see that, okay, this is my for loop. I have a for loop from I equals 0, I less than 5, which is going to print for me 0, 1, 2, 3, and 4. Okay, but after you end your for loop, you cannot print I. After the loop I is no longer valid. If I actually put, if you want to output I here, yeah, let's output I, it should give me an error. Okay, so it gives me an error because it's not declared. To resolve this, if you want to have the value of I after you need it after the for loop, okay, you have to remove integer from here, and in here you put integer I equals 0. This will work. Should work now. Okay, and after the loop, the value of I was actually 5 because it broke the loop when I became 5. Oh, what you can also do is you can remove this at all. You can keep it as an empty so you don't have an initialization phase because it's already before the loop, and this is also valid, as you can see. This is a very good notation that you can keep. Okay, the comma operator, let's look at the comma operator here in an example as well. So you can have more than one Okay, you can have more than one term in each of the phases, in the initialization phase and in the incrementation phase. Okay, you can have two counters, you can have any declaration part. Okay, such that they should be actually separated by commas. So as you can see here, I have two counters, I plus plus and j minus minus, and I'm adding up sum plus equal I times j, which means I'm adding up sum is equal to, as you can see, sum started with 0, sum is equal to sum plus I times j. Okay, that's equivalent to this. And I could have put here sum equals 0 and removed the sum equals 0 from here. Okay, or if you put it like this, it's going to be redundant, it doesn't do anything, but you can do whatever you want. But what I'm trying to say here is that you can have more than one counter here, more than one counter here, more than one statement. As you can see, the output did nothing expectedly because we don't have a printf statement. We can print off the sum is, and its type is integer, so we put %d, comma, sum. All right. And don't forget the semicolon here. Let's run it. So the sum came up to be 70. I can do here, I can actually, I can put here and, let's say, or you can have two conditions. I put or, let's say j is greater than 0, so if this is true or this is true, and we were saying j minus minus and start with 10, so I'm going to have the sum is equal to 165. Let me run it again. Okay, so we can have, you can, so the point that I'm trying to say here is that you can have a comma in each phase of the for loop. You can have it without an incrementation or a decrementation, and then it is going to be an infinite loop, let's say. Okay. Another thing to show is this. Yeah, so this is an infinite loop. Okay. Let's look at this infinite loop here. So this is an infinite for loop. Let's see how it's going to execute. So for int I equals 0, I less than 5, j plus, as you can see, I is equal to 0 and it's less than 5, but in here I didn't change I changed j. So this is going to be an infinite loop. It's supposed to print me zeros. Something wrong happened. Okay, so it's an infinite. Still, you cannot notice it, but it's going I equals 0, I equals 0, I equals 0. All right? It will never go to this line. So this line will never execute. It will never end the for loop. Okay, to resolve this, you could put here what? I plus plus. Okay, so sometimes we do this as a mistake as developers when we're writing a program. This could be a mistake. Something went wrong, suppose. Okay, so in this case, when I put I plus plus, it wouldn't be an infinite loop anymore. Okay. Another infinite loop is this one. Next week lecture, I'll be talking about a break. Okay. But an infinite loop is a while true. If you could put while true, this is an infinite loop. Okay. But if we remove the if break here, so the only way for this while loop to exit is for it to have this if. If we remove this if, let's remove it. So if we remove this if, it's going to be an infinite loop. Yeah, so if we do that, I changed true to 1 because it recognized it in the GDP compiler. So if we do this, it's going to be an infinite loop. So enter a month, let's say 2 Please enter another month, 3, okay, so it's not gonna exit, whatever, 56, 70, whatever you put. So I'm sorry, but 67 is not a valid month. Please try again, but still it's asking for the month. It will never exit the loop. So whenever you have a while, which is always, whose condition is always true, what you do is that you have to have a break. So the break, what does it do? I'm going to explain it in the next lecture. So it's asked me to stop because the program is still running. It didn't end. Okay, so the break, it takes me out of the loop. Okay, so I need the break in order to break the statement. So when will it break? If the month is greater than 0 and the month is less than 13, then it will break. So it's going to take from me only 1 month. Let's try it again. Please enter a month. Let's say 2. Okay, that's it. It took 1 month only. It was supposed to take only 1 month. Or if I give the month wrong, it still asks me until I give it a good month. So it told me a valid month number. So in here it told me it's not a valid month. Try again. So the aim of this while loop is to loop as long as I'm giving a wrong month. 34, 13. Okay, this is also a wrong month. Okay, it loops. So while true, when will it break? When will it exit the while loop? Read it with me. When will it exit? When the month is within the months that we know is within numbers 1 to 12. Only then it will exit. So it will stop the loop. So if I give it 1, that is January, okay, that's it. Now it took the month. So while 1 means while true, it always loops, okay, infinitely. Okay, if you have such a loop, you have to use an if with a break in order to break the statement, the while statement. And in this case, we used while 1 in order to keep on asking for the month until you give me a correct month. That's exactly what it's doing. Empty loop, we can have something called empty loops. Okay, can you have an empty loop? Yes, you can. Okay, so let's see what an empty loop looks like. So this is an empty loop. So this is a loop that has nobody. There's nobody. So let's run to see what this will do. So when you have a semicolon after the loop, okay, if you have a semicolon, if you see this in the exam, a semicolon after the for statement, this means this is an empty for loop. So this is not inside the body of the for loop. Okay? Did you get it? So sometimes you will put this by mistake. We're saying that this is an error. Don't do that because you don't want an empty for loop. Okay? So this is a common error that you would put a semicolon here. So that's wrong. But it wouldn't do an error. We're saying it's an error because it's semantically or it doesn't have any meaning. You wouldn't do that. You have done a mistake here, but it will run anyway. It will not trigger an error. It will trigger that the body of the for loop is empty. There's nobody. Okay? And this printf is outside the for loop. And we were able to print I because I introduced integer I before the for loop, and that's why it can see it. If we remove this line and we run it, this is going to give me an error because this is not inside the for loop because there's a semicolon here. Okay? So the thing that you have to understand is that when you have a semicolon, okay, this means the body is empty. It's not doing anything. And this line is outside the for loop. That's the point. Okay? Similarly with the while loop. So also in the while loop, if you put a semicolon here, same thing. The body of the loop ended, the while loop structure ends here. This is outside the body of the loop. Now, nested loop example. This is an example of a nested loop. Let's look at it together. rows and columns as you saw in the lecture. Okay, so what do I have here? I have integer number of rows and integer number of columns, and I have defined them to be constants in that I'm not going to change these values. So I'm going to loop through the rows and then loop through the columns. And as I have discussed in the lecture, for each R, we're going to loop through all. This for loop is going to be executed, exhausted until it ends, and then I will take another R and then another R. So this is the idea of the nested loop, is that for each iteration of the outer loop, you have to finish all the inner loop. Take another value for R, and you have to do all the inner loop. So the inner loop is done how many times? The inner loop is executed R times, unrows times, okay? And the body of the for loop, okay, is this statement is going to be executed how many times? As much as uncolumns times unrows, because it's going to do uncolumns for each unrows. So that's trying just to understand it better. Okay, so this is what's actually doing. It's actually printing printf R times C. It's getting R times C. It starts 0, 0. Okay. So the first line is 0, 0, 0, 0, 0, 0, okay? Then this is for what? This is for R equals 0. So for R equals 0, we executed all the for loop, the inner for loop, which is printf %5d, which means that you're going to leave 5 spaces and it's going to be right aligned. If you put a dash, it's going to be left aligned. So without a dash, %5d will give you 5 spaces, right aligned. So R times C is put, you see, in the first line for R equals 0. Okay, and C is going to start with 0 and change C++, C++ until it reaches to n columns. Okay, then it will stop. So for each value of R, so for each row, I'm going to do all the columns. That's what the nested loop does. Row plus plus, R plus plus, it became 1. And now at 1, I'm going to do the for loop for all the values of C from 0 to n columns, which is 10. So from 0, this is 1, from 0 to 10. Okay? So R plus, we finished all the inner for loop. So this is a multiplication table. We finished all the inner for loop. Now R plus plus, now for the value of 2. For R equal 2, we're going to do all this line, the iteration of all the inner for loop. Okay? Which is R times C. For all the values of C. C starts at 0, 1, 2, 3, till we reach, not 10. At 10, we will not enter because it's not less or equal. If we put less or equal, then it will add 10 here. So if you put here less or, as you can see, it ends at 818. If I put here or equal and run again, okay, what it does, it did the for loop, okay, until 20, not until 18. Okay, all the values of column. So for each value of R, all this for loop has to be executed from 0 to n columns. For R equal 3, R plus plus, R became 3, it executed for all C. R plus plus, now R is equal to 4, you do this for loop. This is the multiplication table of 4. Okay, so when does it end? At 9. Okay, for R equal 9. Okay, when R became 9, you have to do all the inner for loop. So for each value of R, you do all the inner for loop. That's how nested loop works. If we put here less or equal, we'll add another R, another row, which is R plus plus. It will be 10. And then at 10, you will execute all the columns. Let's see it. Okay, now you added one for the rows as well. One of the rows, which is for number 10, for R equal 10. Please pause and write it down, and it should make you understand nested loops very well. The idea of the nested loop is that this is the body of the for loop. Okay, this is the body, including this one. Okay, so this is the body of this for loop, and this is going to be executed for each r. So at r equals 0, all this is going to happen. That's why when it enters the for loop, it has to finish the for loop. So to finish the for loop, it goes through all, you see this row? So it has to go through all the columns. Column equal 1, 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And the slash n is not inside. This is the for loop. This is going to be repeated 10 times, right? This is 10 times at each row. But the slash n is in the outer loop. So it's going to be executed 10 times. How many slash n's do we have? Only 10. However, this line is going to be executed 100 times, because for each one here, it's going to be 10. 10 times 10, that's 100. So in here, you have 100 values. 100 C times R, okay, corresponding to this statement here. And the slash n, backslash n, is done only 10 times because it's only inside the outer for loop. So the outer for loop body is executed how many times? N rows time, and n rows is equal to 10, so 10 times. So the for loop, all of this for loop, its 10 iterations are going to be done 10 times in addition to a backslash n each time. So 10 times for loop is gonna do this line 10 times and then backslash n, and that's exactly what was done. Please, if you still don't understand it, you can repeat what I have said. Now, these are some tips on when to use the while loop. So if you know, or you can calculate how many iterations you need, if you know how many iterations you need, then you will use a for loop. If you know how the counter-controlled for loop, it's easy when you know how many iterations you have, or there's a pattern that you want to follow, let's say printing even numbers, odd numbers. Yeah, so whenever you know the iterations, how many times, and you can do a counter-controlled for loop or a while loop, but it's advantageous to do a for loop like in the multiplication table. So usually a multiplication table, you would do a nested for loop. If you don't know how many times you're going to execute the loop, then you would use while loop. Okay. If you want the body to be executed at least once, regardless of the condition, whether it's true or false, you want to do it at least once, then you would use a do while loop. Here you have some exercises, okay, for those. I saw some students that are interested in doing more work, okay, do it. If you have any questions, you may always send me an email, and I'm going to check it out, and I will share your questions with all your friends and answer in a recording to make sure that you all understand everything very well. All right.